Hello, in this video I'm going to be solving this system of simultaneous equations using Gaussian elimination. The first thing I'm going to do is rewrite the system as its augmented matrix. So first row, second row, and third row. 2, 1. I'm going to put a line here just to represent that's where the equal sign is, and this is my augmented matrix. Oops. Okay, so the first thing I'm going to do is I'm going to swap row 1 and row 2, so I have a 1 in the pivot position here. So my row 1 is going to become my row 2, and vice versa. So the new matrix is going to be 1, 1, 1, 1, and the second row is going to be 2, 1, 3, 1, and 3, 1, 2, 1. I close the matrix and put our line here. Okay, now the next step, we're gonna make this 2 into a 0 and this 3 into a 0, and obviously all the values in those two rows are gonna change. To get those zeros, we're gonna do minus 2 times row 1 plus row 2, and minus 3 times row 1 plus row 3. If we do minus 2 times 1 plus 2, we get the 0. Then minus 2 times 1 plus 1, we get minus 1. Minus 2 times 1 plus 3, we get 1. Minus 2 times 1 plus 1, we get minus 1. And then we do the second operation for row 3. Minus 3 times 1 plus 3 is the 0. Minus 3 times 1 plus 1 is minus 2. Minus 3 times 1 plus 2 is minus 1. And minus 3 times 1 plus 1 is minus 2. Now at this point, what I'm gonna do is I'm gonna multiply the whole row 2 by minus 1, so I get a 1 in my second pivot position. So it's gonna be minus 1 times row 2, and that is gonna give us the new matrix. Now to get a 0 in this position down here, we're gonna multiply 2 times row 2 and add that back into row 3. And this is the final matrix we are getting. We only have one value in the last row, so we can now solve for z. And just looking at those values there, we get that minus 3 times z equals 0. Therefore, z is equal to 0. Then we go into the second row, y minus z equals 1, which means y equals 1. And then we sub into the first row that says x plus y, but y is equal to 1, plus z, which is 0, equals 1, which means x is equal to 1 minus 1, 0. And this is the final answer, 0, 1, and 0.